Hello friends, welcome to the Theoretical Computer Science lectures. In our previous video, we have seen the concept of NFA with epsilon transition. So in this video, we are going to see the next concept, which is epsilon closure. So what does it mean by this epsilon closure? Epsilon closure for a given state X is a set of states which can be reached from state X with only epsilon moves, including state X itself. Right? That means we have to find all the states which can be reached from present state on one or more epsilon transitions. Let's have an example so that you get the concept of epsilon closure. So, here we are going to see the NFA with epsilon transition Q1, Q2, which is a final state. So, Q0 carries epsilon to Q1, Q1 carries epsilon to Q2, and Q0 carries 0 to itself, Q1 carries 1 to itself, and Q2 carries 2 to itself. Right. Now, we have to calculate the epsilon closure of each state. For calculating the epsilon closure for each state, we have to calculate the transition function of that particular state. So, now we have to calculate the epsilon closure of Q0. Before calculating the epsilon closure of Q0, we know that as our rule says, when we calculate the epsilon closure of any state, we have to add that state itself. That's why when we calculate the epsilon closure of Q0, we have to add that Q0 in our closure set. Right? Now calculate the transition function of Q0 for the input epsilon, which gives Q1. Therefore, we have to include Q1 in our closure set, right? Now again calculate the transition function of that Q1 for the input epsilon, which gives Q2. Now add that Q2 in our closure set. Now we are going to calculate the epsilon closure of Q1. As we know that when we calculate the epsilon closure of any state, we have to add that state in their epsilon closure set. Therefore, we are going to add Q1 here. Now calculate the transition function of Q1 for the input epsilon, which gives Q2. Therefore, include Q2 in closure set. Right. Now, let's calculate the epsilon closure for Q2. Here we have to add that Q2 in his set. Now, as our Q2 is a final state, that's why we stop here. But when we calculate the transition function for Q2 for the given input epsilon, it gives 5. Because Q2 don't carry epsilon to any state, right? Therefore, we are going to stop here, right? So, by this way, we calculate the epsilon closures for different states. So, in our next video, we are going to see the conversion of NFA with epsilon transition to simple NFA, in which we are going to see the epsilon closure concept as well. So, till then, stay tuned and thanks for watching the videos.